You know, in every single modern building, from a massive skyscraper right down to your own home, there's this hidden central nervous system. It's quietly managing the flow of all that electrical power. It's really the silent, unsung hero that keeps our world humming along. So today, let's pull back the curtain on this hidden world.
So what is this hidden brain, really? I mean, think about it. What's actually happening behind the scenes when you just flip a switch or plug in your phone? Well, the answer is way more complex and, honestly, more fascinating than you probably think. It's this marvel of engineering, and it's hiding in plain sight. And here it is, the electrical panel, sometimes called a switchboard. Now, this is a seriously sophisticated piece of equipment. It basically acts as the command center. It takes in a huge flow of electricity, and then it intelligently controls and distributes it, all while housing the gear you need to measure what's going on and, most importantly, to protect the entire system from going haywire.
But why bother cramming everything into one box? Well, there are 4 really good reasons. First, it's all about giving you reliable, precise control and protection. But it's also about being smart with resources, making the whole system cheaper to build and way easier to fix or maintain. And really, above all else, it's about safety. It's not just about protecting expensive equipment, it's about protecting us, the people who use it every single day.
Okay, so you might be thinking a panel is just a panel, right? Well, not exactly. They pretty much fall into 2 big families, and the main difference between them is the amount of electrical pressure, or voltage, they're built to handle. And this is the first big thing we need to get our heads around.
So on one side, you've got your medium voltage, or MV panels. These are the absolute heavy hitters. You'll find them in places like power substations, managing just enormous amounts of energy for entire city districts. And then on the other side, you've got the low voltage, or LV panels. These are the everyday workhorses you find inside almost every building you've ever been in, safely handling the power for our daily lives.
Let's actually break down the differences here, because they're pretty stark. The voltage range alone tells a huge story. Medium voltage panels can handle up to 36,000 volts. Meanwhile, low voltage panels top out at around 1,000. That massive difference changes everything from where you find them to the kind of circuit breakers they use. MV panels need these highly specialized breakers that use a vacuum or even SF6 gas, while LV panels use more common types like air, molded case, or even the little miniature circuit breakers you probably have in the panel at home.
So, what's actually happening inside one of these metal boxes? Let's pop the door open and take a look at the vital organs that make the whole thing tick. It's a really beautifully organized system, all meticulously designed to manage that flow of power as safely as possible.
The path that the power takes follows this really simple, elegant logic. You have a main line that brings all the power into the panel. That then connects to a set of bus bars, which act like a central distribution hub. From there, the power gets divided up into all the individual circuits, and each one is guarded by its very own circuit breaker. Only then is it safely sent off to do its job, powering our lights, outlets, and machines.
Now, right at the heart of all this distribution is the bus bar. Seriously, think of it like the main artery of the panel. It might just look like a simple strip of metal, usually copper or aluminum, but it's engineered to handle a massive amount of current and route it to all the different circuits safely and super efficiently. A simple component, but incredibly important. And if the bus bar is the artery, then the circuit breaker, well, that's the guardian. It's this intelligent automatic switch that is constantly monitoring the flow of electricity. If it ever detects a dangerous surge or a short circuit, bam, it instantly trips, cutting off the power to prevent fires or damage to your equipment. It is the panel's most critical safety feature, and it's the reason you can just go and flip a switch to get the power back on after a minor overload.
All right, now that we've seen the guts of the operation, let's zoom back out for a second. Because panels are absolutely not a one-size-fits-all kind of deal. They are highly specialized pieces of equipment, engineered and classified for an incredible variety of different jobs and different environments.
I mean, they're classified in so many different ways. For instance, is it going to be sitting outdoors, exposed to the rain and sun, or is it going to be in a protected indoor space? Is its job just to distribute power, or is it a control panel for some complex machinery? Is it a huge freestanding unit or a smaller one you can mount right on a wall? Every single one of these classifications demands a completely different approach to how it's engineered.
Now, one of the absolute cleverest designs out there is the draw-out panel. Just imagine you're in a hospital, or a data center, or a factory floor, somewhere you absolutely cannot afford to just shut off the power for maintenance. This design lets a technician safely pull out a single circuit module, just like a drawer, and service it or replace it, all while the rest of the system keeps running. It's an ingenious solution that is absolutely essential for keeping downtime to a minimum in critical operations.
So how do these complex systems actually get built? Well, it's a lot more than just slapping some parts together in a box. There's this meticulous, often completely unseen process of design, fabrication, and installation. And the whole thing is governed by really strict rules to make sure every single panel is safe, reliable, and built to last. Yeah, everything is built on this foundation of safety and precision. The designs have to conform to these rigid international standards. Then, fabrication starts with incredibly detailed engineering drawings, and every single component is carefully picked for the specific voltage, current, and even the environment it's going to have to deal with. And get this, even just moving them to the job site is a delicate operation. They're often top-heavy, so they have to be transported and installed with extreme care. So we've gone on a whole journey here. We went from the high-level concept all the way down to the nuts and bolts, and then back out to see all the specialized designs. And through all of that, one thing becomes crystal clear. These panels are so much more than just metal boxes. They are truly the unsung heroes of our modern, electrified world.
You know, this quote from our source material just says it perfectly. Far more than just a metal enclosure, a modern panel is a sophisticated assembly designed to ensure operational safety and system reliability. In other words, they are the quiet, reliable foundation that our modern lives are built on.
So, the next time you walk past one of those gray metal cabinets in a hallway or a basement, maybe you won't just see a box. Will you see the central nervous system, the command center, the unsung hero working silently 24/7 just to keep your world powered on?